All right, so we are combining two sections today, 2.3a and section 2.3b. The first one deals with slopes and intercepts, and the second one deals with the slope-intercept form. So I just kind of combined the titles. Like I said, these two lessons are pretty much the same thing, just an extended version of the other. So first off, what is the slope? Okay, so you can think of slope as an incline. Okay, so an incline or decline. Okay, you can think of a hill that's rising or falling, right? So we can think of like a hill that rises or falls. Okay, so a lot of times in math they always draw lines, right? And the lines would look like either they're going uphill or maybe it looks like they're going downhill, right? So it's either a line that rises or falls. It just depends on what's happening. Now, if it rises up, we say it has positive slope. Okay, so this has positive slope. Okay, and if it's falling down, we say it has negative slope. And literally negative slope. That means that the answer should be a negative number. So the slope could be like a -3. That means it's going down with a slope of 3, right? The negative means down, and then the 3 is the slope itself. Okay? Or you could say, well, my slope is 3/4. Okay, well, 3/4 is positive, so that means it's going up. Right? If I say my slope is -1/8, well, negative, that means it's going down. Right? The 1/8 and the 3/4, we'll talk about that right now, but that's your rise over run. So what is slope? Like I said, one more thing to kind of give you guys a definition. Slope is rise over run. And you guys have probably heard that. Now, I also like to call it fall over run. That's up to you if you want to kind of make a little note on that. But rise if it's positive, fall if it's negative, right? If it's a negative slope, it's going to go down and to the right. Okay, we'll talk about that in a bit, but it's going to go down and to the right, not up and to the right. Up and to the right means it's going uphill. Down and to the right, it's going downhill. Okay, so for me, slope is either rise over run or fall over run, depending if it's positive or negative. So how do we calculate it? Well, this is what we do. We call it m equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where the points are x sub 1, y sub 1, and x sub 2, y sub 2. All right, so we're given 2 points, x1, y1, x2, y2. Now, excuse me. Those points obviously don't look like that. It'll be like 2, 3 and -4, 8 or something like that. But they're going to be given to us in that form, and we just got to plug it into a formula. Okay? Now remember, slopes can be positive, slopes can be negative. Okay? If the slope they give you is negative, so if they give you something like this, if you calculate it and it says like -2/3, that means what you're going to want to do is go down 2, then right 3. Okay, whenever we say rise over run or fall over run, we always run right. Always run to the right side. I'm sure you guys remember that. Okay, but the negative will tell you either go up or down. Okay, if the negative is there, you go down. If it's a positive, you're going to go up. So, for example, if you have, let's see if you guys remember. What if I tell you my slope is just a +3? So I have to go up 3 and to the right how many times? 1, right? If you don't see a fraction, it's there. It's just kind of hidden, right? It's like this little invisible number there, right? Negative 3 over 1. So anytime you see a whole number, you can always write it as a fraction, just put over 1. Okay? So in this case, the slope is positive, so I know I got to go up 3 and 1 over. Okay? So let's find the slopes of these lines. I'll give you a little bit of time to write these out. So let me just pause it real quick. All right, so for example, number 1, we're finding the slope of each line. For part A, is this a positive slope or a negative slope for part A? Positive. You see how it's going uphill, right? What about part B? Positive or negative? Negative, right? It's going downhill, right? As we go left to right, it's going downhill. So I already know my answer is positive for part A and it's negative for part B. So you know what? I'm just going to write it down. I'm just going to write it down as a negative for part B. Okay, because I already know that just by looking. Now, I'm going to show you guys how to do this 2 different ways. Okay, but first I'm going to do counting. After that, we're going to do calculation. These are calculations right here. Okay, but first I'm going to do counting. So I'm going to go from left to right. I'm going to start with 1 point, this point right here. Okay, and then I'm going to look at the next point, and I'm going to say, all right, I want to get to the next point. In order to do that, do I have to go up or down? Well, I got to go up. How many times do I need to go up? Well, 1, 2 times. I went up twice. And then from there, how many times do I got to move right? Well, 1, 2, 3, 4, 5. 5 times. So my slope is 2/5. Now this took me forever because I actually was drawing lines, okay, or curly fry lines. I don't know, whatever you want to call them. So when you're doing this by yourself, you don't have, just go with your pencil real quick. 1, 2, 1, 2, 3, 4, 5, 2/5. Got it. Okay. For part B, I'm going to start with this one right here. And then I have to go down to the same level as the next point. So I'm going to go 1, 2, 3, 4. So I went 4 times down over 1, 2, 3. So that was 4 down and 3 over. So negative 4/5. Okay, I love these problems. These are pretty easy. It's just kind of trace with your finger, trace with your pen. Pretty simple stuff. Are we okay with these? Any questions on these? These are easy. So are these. Just that these actually require calculation. Whereas the other one I kind of do is just use your pencil. You can figure it out. For these, what we want to do is find the slope of the line through these points. And I'm giving you a set of points. Okay. Remember, you have a formula that you're supposed to use. M is equal to y2 minus y1 over x2 minus x1. So I'll label that stuff right now for us. Okay, but we're going to find the slope of the line through these points. And we have 2 different ones that we are working on. These are homework problems, by the way. The first 2 were not because they're pretty easy. But these, I figure I'll help you out with these. I think you have 4 problems like this on your homework, so I can do 2 of them for you. All right, so this is what I do. Even to this day, I still do the same thing. I get my points and I label them. Okay, so I'll call this x1, y1, x2, y2. The 1s and the 2s to me mean first point, second point. So the x of the second point, the y of the second point, that's x2, y2. x1 means the x on the first point, right? y2 means y on the second point. If there was a third point, I'd call it x3, y3. Okay? So let's write our formula. M is equal to y2 minus y1 over x2 minus x1. Again, I like writing the formulas. You don't have to if you don't want to. I just think it's good practice, easy to memorize. So y2 is 7 minus y1 is 10. You're going to notice I always put the second number in a parenthesis. I do that on purpose so I don't forget about the negatives, okay? You don't have to do it if you don't want to, but it's a really good strategy. Second one, x2, that's negative 13, minus x1, that's negative 14. Notice how I have a minus and negative on the bottom? And by putting that parenthesis there for the second point, I'm making sure I don't forget about the two negatives becoming a positive, right? So on top, 7 minus 10 is negative 3. On the bottom, this is negative 13 plus 14. Well, negative 13 plus 14, that's a 1, right? Positive 1. So my answer is negative 3 over 1. Or if you just want to write negative 3, that's perfectly fine. Okay? I'm okay with that. But there's your answer. I like doing slope like this as well. I know it takes us a while because I'm talking us through it, right? But when you do it by yourself, it's usually pretty quick. So let's do the other one really quick. I'm going to give you a minute. Try to calculate, okay? And then I'll come back to the recording. But let me first label these things up here. So x1, y1, x2, y2. All right, so let's go over this and see if you guys got the right answer, if you did finish it. So again, I'm going to put my formula here just because that's what I like to do. It's an easy way for me to memorize things without really trying to memorize things. So here you go. So y2 is negative 5 minus y1 is negative 16 divided by x2, which is negative 14, minus x1, which is negative 6. So this is negative 5 plus 16 and negative 14 plus 6. Negative 5 plus 16, that's 11, right? And negative 14 plus 6, that's negative 8. By the way, if your answer has to be simplified, make sure you simplify or reduce, shall I say. If that was like a 2 over 4, make it a half. Right? But there you go. Here's your answer. Negative 11/8. Are we okay with those first two examples? They're pretty straightforward, right? This is still part A from your homework, okay? Part A ends after this section, this x and y intercept stuff. All right? So what are x and y intercepts? And how do we find them? And after that, we'll do a real quick example. I think it's just one. And that completes part A. And then after that, we'll jump into part B. So part B assumes you have already been taught everything that we did in part A. And we're just going to go over one really quick formula. So I'll give you a little bit of time to write that down. So what are the x and y intercepts? And how do you find them? Does anybody know what x and y intercepts are? Anybody remember them from before? What does it mean to intercept? Cross, right? Those of you guys that watch football. It's called an interception because the ball was flying in one direction, but all of a sudden, someone came in and got in its way, and they crossed. And when they got it, they call it an interception. Same thing. It's an intercept, right? Two things cross. Okay? So when two things cross. So what are x and y intercepts? That's when a line crosses the x and the y axis. Okay? So this is when a line crosses the x and y axis on the coordinate plane. Okay, the coordinate plane is the graph, right? X and y axis. The actual name of it is called the Cartesian plane. It's named after René Descartes. But we don't really say the Cartesian plane anymore. We call it the coordinate plane. Okay, because that's where all your coordinates are, right? Your positive x's, positive y's, negative x's, negative y's. They're all right there. So when the line crosses the x and y axis on the coordinate plane, now it doesn't always have to cross both, but most of the time they do. Okay, how do you find them? Well, you make a little chart and you calculate them. Okay, so you're going to create a t-table And you're going to plug in your zeros like this. I know this sounds really weird to do, or it looks really weird because normally we don't do things diagonally, almost like a backward diagonal. But that's what you want to do, because when you solve and you plug in 0 for y the first time, this will give you your x-intercept. Okay, so you're going to plug it into the formula. You're going to plug in 0 for y, and then you're going to solve for x. Once you find that value, you can put it in that little empty spot. That'll give you your x-intercept. And then you do it again, but this time you plug in 0 for x. And that's going to give you your y-intercept. Okay? If you put the zeros in the opposite direction, meaning right here and right here, look at the green ones, that's fine. It's just that first you're finding your y-intercept, then your x-intercept. I like doing things alphabetically because it makes more sense, right? X, y. So if you want to do it alphabetically, you're going to use those numbers. So all you're going to do is plug in the zeros and solve. Remember, just one at a time. Don't do both. Okay, just plug in the zeros and you solve. And that's it. And then they'll sometimes tell you like, oh, well, graph it. Well, that's pretty easy. Don't worry. We'll get to that. So you can plug in those zeros. So that little chart is what we're going to do. So right here it says find the x and y intercepts and then graph the line of 2x plus y equals to 4. So again, this is the end of part A. So find the x and y intercepts and graph the line for 2x plus y equal to 4. So I'm going to make a t-table. I'm going to put my zeros right there. All right, and the graph I already had it set up, so that's fine. You guys will also have graphs already pre-done for you. I don't think you're going to have to make them yourself. And I'm going to start plugging in my value. So I want to plug in y equal to 0. So here we go. 2x plus 0 is equal to 4. Well, 2x plus 0 is just 2x. And that's equal to 4. So if I divide both sides by 2, I get x equal to 2. That's my x-intercept, 2, 0. Okay? This is 2, 0. So I'm going to go to 2, 0, and I'm going to put a dot right there. 2, 0. Notice, x-intercept because it's crossing the x-axis. Now let's find my y-intercept. So for the y-intercept, I get to plug in a 0 for x. So 2 times 0, because x is going to become a 0, plus y equals to 4. 2 times 0 is 0. And 0 plus y is just y. So my answer is y equals to 4. So I'm going to put that right here. The point is 0, 4. And I'm just going to put a dot at 0, 4. So 0, 4 is right here. That's my y. Now all I got to do is graph the line. So here we go. And I'll just go this way as well. Forgive the fact that it's a little crooked, but that's fine. Okay? And that's it. So I got the x and y intercepts, I calculated them, and then I just put them on a graph and drew the line. Wait till class. Are we okay with this one? There's only one example here. I'm not going to do another one. So just plug in the numbers, calculate it, plug those points into the graph, connect the dots, and you're done. So again, this is section 2.3a. All right? 2.3b asks basically this question. Is there a faster way to do it? Right? Do I have to calculate points? Do I have to find slopes by calculating these points and then from there, like connecting dots and stuff like that? Is there a quicker way for me to do it? Obviously, the answer is yes, or else we wouldn't be teaching a lesson on it, right? there is a faster way, and the faster way is slope-intercept form. Okay, so I'm going to give you that definition right now. All right, but there is definitely a faster way. It's actually probably the most accepted way to graph. Okay, so I'm going to put right here, yes, it's called the slope-intercept form. Sometimes I'll abbreviate it SIF. Okay, not often, but sometimes I might. So, a slope-intercept form looks like this. All you got to do is you're going to take any equation, you're going to solve it for y. Okay? But we're going to write it like this. Okay? Once you solve it for y, this is your slope. M. Not mx, just m. Okay? And then b is your y-intercept. This is where it crosses the y-axis. Okay? Now this is the way I tell people to remember how to graph with this. I say, you're going to first begin at a certain point, and after you begin there, then you're going to move. Okay? So once you've solved it, your b value is where you begin. You're going to go and put a dot right there. And then from that dot, you will move according to your slope. Okay? So M and B, begin and move. That's the order in which you want to do it. Begin and move. Okay? Let me just check something. I think these are the last ones, and yeah, okay. So these don't take very long, thankfully. A and B. I just want to write the slope-intercept form. In other words, I just want to solve for y. I don't want to graph it. Just solve for y. Okay? So write the slope-intercept form of the equation. The first one says 3x plus 4y equals to negative 24. So I got to solve for y. That means I got to move the 3x to the other side. I got to get everything away from the y. Okay? So let's move the 3x over. So this will be 4y equal to negative 3x minus 24. Remember, the 3x is positive. When I move it to the other side, it's going to become negative. Well, to get the y by itself, I have to divide everything by 4, right? So divide by 4, divide by 4, divide by 4. That gives me y equal to negative 3/4 x minus 6. And I'm done. That means that if I was going to graph this, I would start at negative 6 on the y-axis. And then from negative 6, am I going to go up or down 3? Down, right? Because it's a negative 3/4. I'm going to go down 3 and 4 times to the right. And that'll be my next point, then I just connect the dots. Let's do the same with part B. I got to solve for y, so I'm going to get 3x and I'm going to throw it over. So that's going to be negative 2y is equal to negative 3x plus 0, but I mean the 0 doesn't do anything, so I'm not going to write it. So my next step is to get the y by itself, so I'll divide everything by negative 2. So y is equal to 3 over 2x. And here's my answer from my slope-intercept form. What's my y-intercept? It's supposed to be the b, right? It's supposed to be a plus or a minus something at the end, but it's not there. What's my y-intercept? 0. And then from 0, do I go up or down? Up 3 times, 2 times to the right. For you guys. Okay? So, all right, not a big deal. Once you have them solved, so notice part A, just draw a little sketch for yourself if you want. You don't have to draw anything like amazingly large, but they're going to tell you sketch these. Okay? Sketch doesn't mean it has to be perfect, preferably kind of straight, but if the lines are a little crooked, it's okay. All right? Just make sure you pass through the 2 points that you're going to do, okay, that you're going to need to have on your graph. Okay? One of those 2 points is going to be your y-intercept. Where's my y-intercept here? -4. I did not shut down my volume. Give me a second. So this is my y-intercept. This is b, right? Which we have as our y-intercept. And this is m, which is my slope, okay? So I'm going to start at -4. I'm going to put a dot at -4. So there it is. And then according to my slope is a +2. 2 over 1, right? If it doesn't have a fraction, you put it over 1. So from that red point, I'm going to go up twice and once to the right. So up twice, once to the right is right here. And all I got to do, connect the dots, and I'm done. Okay? Honestly, really zero effort for this one. Just a little bit of, put a point here, put a point there, connect the dots, and there we go. Okay? Remember, identify your y-intercept, identify your slope. Okay? Let's do the next one. Obviously, I can't make them both that easy, right? What do I have to do first before I can graph? We got to move the x over, right? I got to find the slope-intercept form. Okay? So I'm going to have to move that 3x over and eventually solve for y. So let's do that. Moving the 3x, I get -5y is equal to -3x plus 15. And now I'm going to divide everything by -5. Okay, divide everything by -5. So y is equal to 3/5 x minus 3. So what's my y-intercept here? -3. I'm going to go on the y-axis to -3. I'm going to put a dot right there. And then my slope is 3/5. Up or down? Up 3 times, right? So, and then 5 times over. So 1, 2, 3 up. 1, 2, 3, 4, 5. That's way over here. Connect those dots, and I'm done. Now this last thing is not really an example, but it's just something that's good for you guys to know, because it does come out on your homework and it does come out on tests, and it's supposed to be really easy, and a lot of times people forget. Okay? But before I move on, any questions on these right here? We're almost done. This is the last thing. I said I was telling you 30 minutes. I'm approaching it, so I might have not been lying. That's good. But there's always these weird graphs that sometimes pop up. You see like y equals to 3, y equals -1. And you're like, where's the x? How come there's no x and y? Okay? So whenever you have an equation that's like x plus 3y equals 7, the reason why they're diagonal is because they're two-dimensional. They move left, right, up, down. So most of those lines will be like diagonal going up, diagonal going down. If they have two variables, they're two-dimensional. They go up and down, like that, okay, diagonally. But if they only have one variable, they're one-dimensional. That means they either just go straight up and down, or just side to side. There's no slope to it. Like it doesn't go like 30 degrees. No, it's either 0 degrees or straight up 90 degrees. Okay? So what if they only have like y equals 2 or x equals to -3? Well, that means they're one-dimensional. Okay? That means they're either going to go side to side or vertical. Okay? How do I know? Well, you see how on the y-axis, the little tick marks are side to side, right? These little tick marks right here, they go left to right, okay? On the y-axis, they go left to right. So if you put a dot right there, and that's all you have. So for example, y equals to 2. I'm going to put a dot right there. But there's no x value in the equation. That means all you got to do is draw the line, but just long, okay? Don't do a little tick mark. Draw it long. And if you have x equal to -3, well, same thing. Notice the tick marks on the x-axis. Aren't they going up and down? All the little tick marks, these are tick marks, okay? This right here. They're going up and down, right? They're tiny, but they're going up and down. That means if all you have is one one thing on your equation, x equal to negative 3. You're going to find negative 3, and you're just going to draw it going straight up, straight down. Again, if there's only one variable in your equation, it's a one-dimensional graph, meaning it either goes up and down or left and right. When you have two variables, that's when slopes start to have positive or negative declines. So they start to do this thing, right, where they're like looking like uphills and downhills. But when they only have one variable, then it only has one dimension. Okay? So I'm going to put it right here. One variable is one-dimensional. Okay, either up and down or left and right. That's it.